Hello, and welcome to an introduction to coding basics in just 3 days. A little bit about myself. First, I graduated from Georgia Tech during the pandemic with a bachelor's degree in computer science. This was a very difficult time for everyone, and I consider myself very fortunate to have been able to complete my degree in the midst of a global pandemic. Second, I worked remotely for about 6 months prior to my graduation for a Fortune 500 company as both an intern and a part-time employee. After I graduated, they offered me a full-time position, to which I am still working there. And third, before I graduated and worked for them, I spent 3 years as a college of computer tutor. I tutored many of the undergraduate computing courses that are taught at Georgia Tech. To the right, you'll see an image of my dog Lucy, who I love very much, and I would even go as far to say she saved my life. The outcomes of this course are the 5 following principles. First, I hope to expose you to the look and feel of Python code to see how it can be used to build software applications. Second, I would like you to understand the basic reasons behind why data structures and algorithms are so foundational to all coding projects. Third, I would like you to be able to read and write basic Python commands to manipulate data. Fourth, I would like you to understand whether coding is something you're interested in and if you're passionate about learning more. And finally, I hope that you can follow along as I show you how to build a basic random Bitcoin trading bot with simple Python. That is all for this video, and I hope to see you in the next one. Basic types, classes, and functions. The basic types of Python, also called the primitive types, are the 4 following: strings, booleans, integers, and floats. Strings can be thought of as just simple words of text surrounded in quotes, either double or single, such as hello world, dog, cat, or this is a sentence. Booleans are true or false values. Integers are whole numbers such as 1, 2, 3, 4. Floats are decimal numbers such as 1.2, 2.4, 3.14, any of the following. These 4 basic types are very common to other languages and do not apply to just Python. They represent the basic building blocks that you will use in many variables. Next, we have classes and functions. Classes, which can also be called objects, hold functions and act as the building blocks of the language. Objects contain both properties and functions that can be either private or public. Private properties and functions can only be used within the object itself, whereas public properties and functions can be used outside the object. Objects are modular by design and take advantage of these public properties and functions to serve as said building blocks. Object-oriented programming is a key concept to understanding how large software applications are built in a modulable, understandable way. Now let's look at an example. What exactly do I mean when I say an object or class? Consider a calculator. A calculator is an object in the real world that performs very simple functions, or very complex functions. But all calculators we think of as having 4 basic abilities. They can add, subtract, multiply, and divide. Given this definition, we can easily create a representation of this in Python code. We can create a calculator class with the 4 functions: add, subtract, multiply, and divide. And that is exactly what we'll be doing in the next video, in which we will cover variables, conditions, and loops, followed by a live coding example. First, let's begin with discussing conditions. It is very common when writing code to want to take different actions depending on the value of a given condition. If, for example, a number is 2 and divisible by 2, then it is even. If it is not divisible by 2, it is odd. In the image on the right, you will see the variable 14 is assigned the number 14. A variable is anything that we assign a value to. Here, the variable is called number, and it is assigned the value 14. If number divided by 2 has a remainder of 0, we will print it is an even number. If the number divided by 2 does not have a remainder of 0, we will print I am an odd number. Because 14 divided by 2 has a remainder of 0, we print I am an even number. Next, we have loops. Looping is a very powerful concept and is used in almost every computer science algorithm. There are two main types of loops, the for each loop and the while loop. In a for each loop, we will iterate through all the elements of a collection. If you are given 10 objects, the loop will run 10 times, one for each element. A while loop is a loop that continues to run until the condition given to it is false. If the condition is never made false, the loop will run forever. Some examples: on the left you'll see the while loop. We have a variable called number to which we assign the value 5. While the variable number has a value greater than 0, we print the number. After we print the number, we subtract 1 from the number. If we did not subtract 1, the while loop would never end and it would continue printing into the negatives. On the right, we assign a collection 1, 2, 3, 4, 5 to the numbers variable. Then, for each number in the numbers collection, we will print the number. Both the left and right print the same thing: 5, 4, 3, 2, 1. And now let's take a look at a live example. So here I am using onlinepython.com to type my code. Let's start with a variable to which we will assign the value 100. Let's write our while loop. While variable is greater than 0, print variable. Let's run this condition. You'll notice it continues to print 100s and it does not stop. I have to manually stop it. Process stopped. Now, let's subtract 1 from variable on each iteration of the loop. And there, that was very quick, but as you can see, it goes and counts down from 100 to 1. That's not quite that interesting, so let's combine this with the if statement. If the variable equals 0. In this statement, the percent symbol is a remainder operation, so it gives you the remainder of variable divided by 2. So in a moment, I will print this value. Well, that doesn't make entirely sense. So instead, I will print the variable with the following string is even. Oh, and this continues to run forever because I did not subtract 1. As you will find in computer science, it is very often to get in a while loop that runs for infinity and that you have to manually stop. So here we can see 4 is even. Well, let's add an else condition. To clean this print up, we'll add the else condition. If it is not even, we just want to print the variable. And now we can remove this first condition. So now what do we see? We see 100 is even, 99, 98 is even, 97, 96 is even, 95, 94 is even, etc. The reason is, for each iteration of the loop, we start at 100. If 100 divided by 2 has a remainder of 0, we print is even. So, because it is even, we print is even. If it does not satisfy this condition, we just print the variable, which happens to be just the number. Instead of the number, we could print condition magnet. And here you will see, instead, we go 100 is even, 99 is not even, so it executes this else logic and prints condition not met. Now let's look at the for loop. We can do this exact same thing given a collection. So we'll have a list. In Python, these brackets denote you are making a list. So we have a list of numbers. And now we want to do for number in list. We can do the same exact thing. 2 is even, 4 is even, 1, 3, and 5 are not even. You'll notice that these are the exact same loop with a very subtle difference. Any while loop can be converted into a for loop and vice versa. There's mostly for the sake of convenience, given that we already have this collection, so we do not need to make a while loop if we are already given the collection. This is the basic premise of conditions and looping. They are very powerful when used together and with other concepts, but for now this is all you need to know. In the next video, we will expand upon this knowledge to show you how you can use basic conditions and looping to build a calculator. I know I previously mentioned that in the last video, but in the next lesson we will actually take the time to build the entire calculator class and use these conditions and loops to multiply and divide using our add and subtract method. And welcome to our first coding lecture. For this video, we will be using onlinepython.com to code our Python. As mentioned in the prior video, we will be coding a new class called calculator. This class will have 4 main functions: add, subtract, multiply, and divide. First, I'm going to turn live autocompletion off because it bothers me. So let's define these functions. In Python, we define these functions with the keyword def, which stands for definition. So we're defining add, subtract, multiply, and lastly, divide. Now, before we can actually use any of these functions, we need to start by giving our class a constructor. This will use the keyword def underscore init underscore. Finally, we will give it self. In this initialization function, we will define the properties of the class, such as self.number of operations, which we will set to start with the value 0. The add function takes the self, a number x, and a number y. We will reference the property number of operations and add 1. Plus equals denotes that we are adding 1 to the current value of self.number of operations. And lastly, we will return x plus y. Return signifies that the value returned by this function is x plus y. Another important note is that the hashtag symbol, this hashtag symbol, is used for comments. In code, comments represent informational text that is not run by the system. So let's comment this code out. Oops. Oh, well, it seems like there's no easy way to comment all these out at the same time. Now let's make a new calculator that equals we will print calc.add 2 and 2. So calc equals calculator parentheses means that we are calling the initialization class, which gives us a calc object. This object, we can access its add function to add these two numbers and return 2 plus 2, which equals 4. The print will print into the console the outcome of the function. And then you see the 4. Now let's continue with the rest of the calculator. Now we need subtract. So we'll again give it self, x, and y. And we will first increment the number of operations. And then we will return x minus y. Now let's try this. So you have 2 plus 2 equals 4, and 2 minus 2 equals 0. Now you will note that I'm not passing the self into these functions. These functions take two variables, x and y, and I'm giving them in the form of 2 and 2. This self variable is denoted and automatically added when I call calc.add. Calc.add knows that the add function belongs to the self. So let's just print the number of operations after this. So 2 plus 2 is 4, 2 minus 2 is 0, and we've completed 2 operations. So we have 2 operations. Now let's do multiply and divide. These will be the same as the other two. So we'll take the same numbers, x and y. Now here, Python supports all forms of mathematical operations, so we can do these very simply. Very simply, just like the other two. Oops. Four, 0, 4, 1. All as you would expect. But that's boring, and that's not the best way to do it. Multiplication is just repeated addition, and division is just repeated subtraction. So, using those principles, we can reuse our add and subtract functions. So for multiply, we want to set an outcome will equal 0. Outcome will be our final answer, and we will return outcome. An important thing to know about code is the concept of looping. Here we'll use a while loop, which means while y is greater than 0, we will do the following. We will take outcome and we will plus equal up. We will equal self.add outcome and x. And lastly, we will subtract 1 from y. So the reason we're doing this is we want to add x y times. So we will simply continue to add x to itself y number of times. And you will see we still have 4. Now let's give this something a little more interesting. Let's do 12 times 4. We run it again and we get 48. 12 times 4 is 48. We add 12 4 times. We can do a similar thing with division, in which we do repeated subtraction. So again, we'll have outcome equals 0. We return outcome. And we'll do the same while loop. While x is greater than or equal to y, we'll continue to subtract. So x equals self dot subtract x and y. Then we'll add the outcome. And let's see if that works. There we go. 2 divided by 2 is 1. Let's do something a little more interesting and say 8. 8 divided by 2 is 4. What about 9? 9 divided by 2 is not quite 4, but that's because our method of division does not account for remainders and only returns whole numbers. So let's add a remainder. We can have a remainder equals x, because anything we have left will be our remainder. As you can see in the while condition, we are looping while x is greater than y. We subtract y from x and add 1 to the outcome. So if we finish this loop, whatever we have left will be our remainder. Now, for the simple purpose of demonstration, I'll replace the outcome with the remainder. Change this back to 9 and see what we have. 1, just as we would expect. But this is not ideal. For this, we need an if condition. If conditions are also very important as loops. They specify one of two actions or one of many actions based on a Boolean value. So here our Boolean condition is remainder does not equal 0. This will either be true or false. If it is true, we would return yes, if remainder does not equal 0, then we have some type of remainder. So to do this, we need to return a string value. str will convert the outcome integer into a basic string type. The reason we need to do this is we want to add a sentence. And sentences inherently use strings, whereas all these numbers before were integers. So we want to have a string sentence that says our outcome with a remainder of. So again here we have 9. So with this condition we would expect 4 with a remainder of 1. Now what happens if we don't have a remainder and remainder equals 0, such as the case of 8? We run this again and we return none because this function has no return value. The reason is because remainder is equal to 0, we don't enter this return statement and nothing is returned. For this reason, we need to add an else condition. So if this condition is not true, we will default to the else condition, in which we will return outcome because it is a whole number division and there is no remainder. And now we have 4. So after all this, what do we think the number of operations are? We have 10 operations. If this confuses you, and we've only done 1, 2, 3, 4 operations, you should not feel mistaken. While it may look like we were just doing one add, one subtract, one multiply, and one divide, because we are using add and subtract in our multiply and divide functions, we are actually incrementing these number of operations in the add and subtract functions themselves. So we have one add, one subtract, 4 adds, and 4 subtracts. Therefore, we have a total of 10 operations. This is a very basic example of how one could code a very simple calculator. You'll note that it has an instantiation for the class calculator, which uses this keyword underscore underscore init underscore underscore self. Here are the properties that are defined. These are public properties, and you can tell because at the bottom part of the code, we are using them right here. In addition, these are also public functions. These functions, as you can see, can be built upon each other and made more and more complex. They work together and increasing complexity to achieve more and more complex operations. As you can see, we only have two operations, x plus y and x minus y, but yet using these while conditions and this if-else statement, we are able to do multiplication and division with only adding and subtracting. This gives a good example of how a class can compound complex capability from basic functionality. This is a key premise in computer science and used in applications all over the world. The simplest of functionality is made in smaller functions, and large, more complex operations use these functions to complete larger and more complex tasks. I hope you follow along and try to code out this example yourself. If you follow along and go to this website yourself, you should be able to type this out just as I have and received the same results. In the next piece of instruction, we will try to review some of the core concepts brought and shown to you, such as while, if, and else. Thank you, and that is all. An introduction to data structures and algorithms. In this video, I will provide a live coding introduction into some basic data structures and some basic algorithms. So let's begin. You'll notice this is the calculator code that we ended the last lecture with. While this code is very neat, it does not take or make good examples of data structures. So let's start with an array. I will leave the calculator code as is in case we want to use it later. So an array in Python is denoted with the bracket symbols. Inside this bracket symbols, we can enter our data, hello, separated by commas. Array. This is an array of strings, but let's see what happens if we add numbers to it. So, as we've seen before in prior videos, let's print an array. 4 elements in array. Well, let's just delete this of strings part because it doesn't quite match since I added the 1. So for each element of this array, we will print. Now, you'll see we print hello, followed by the empty space, followed by world, followed by the number of 1. This is a good example that the array can hold a variety of different types and still works properly. It is common for an array to be of a single type because that is how we get the most useful operations. So let's change this to be an array of ints. And let's make these just some random numbers. This one I don't really like, so I'll make it 24. And again, let's print each of these. Oops. It seems array is not defined because we changed the variable name to be an array of ints. So all we need to do is replace the collection so it appears as such, array of ints. And then we have 1, 24, 7, 68, 9, 40, 10, 24, and 54, 78. So what is some interesting things we can do? How about we define a function in calculator to get the max? So in our calculator class, we'll define a new function, max value of array. We'll give it self, and an array we'll denote as R. Now, let's keep track of the max is negative a billion. We need to set the max to start as a very, very, very low number. So for this sake, I'll just leave it as negative 1,000. And now we'll bring our for loop in here, for number in array, and now we'll add a conditional if statement, if number is greater than max, max equals the number. So if a number is greater than the current value of max, we will assign that number to be the new value of max. And lastly, we will return max. So now let's do calc max value of an array of ints. And let's see what we get. Well, it looks like it didn't do anything, and the reason is we did not print the value. And I will comment delete that. Well, and now we will print this value. We will see 5478. But that might just be the last number, so it may just be a coincidence. So what happens if we take this 768 and add 99 to it? It will now print the new highest number, which is 76,899. We can do the exact same thing, but as a min. Def min value of array. We'll again pass in the self and the array. Here, we will set the min to be equal to 1 million, or, well, a sufficiently great positive number. Now we want to do the same thing. While number, or for each number in the array, if number is less than the current value of min, assign min that number's value, and then return min. So what is the min value of this array? It is now negative 21. What if I add a new minimum value, negative 346? See, the new minimum is 346. Now let's add some strings to our text. Now remember, when you're printing a number in combination with the text value, you need to add str and encompass the number in parentheses. This will cast the integer or float or Boolean primitive into the string primitive type to allow you to use this plus symbol to combine the two string values. Again, as I just said, we need to make this value into a string by adding str. And there we go. The max value, 76,899, and the min value, negative 346. This is a very simple algorithm we added to our calculator that lets us find a minimum and greatest value of a given array. They're very much more complicated algorithms, and this is barely scratching the surface of the power that data structures and algorithms can have. But for now, I think it serves as a good example to show you how an array looks in Python with the bracket notation, and how you can iterate through that array to find useful information. In this case, the minimum and maximum values of the array. Thank you, and I'll see you in the next video.